Good morning. Today we have to analyze the concept of function points. That is the methods that will allow software engineer to evaluate the dimension of software project. We are interrupting for a while the analysis of current software architecture, so we are moving away for today's class from the web service and service-oriented architecture, and we are getting back to a more managerial, if you like, aspect that is very important in any case during the development of project. The issue that we want to address is the following one. I am required to develop a software system, and I need to evaluate how much is the dimension of this software system in order to give an estimation of how much time and how much is the cost to be required to the client in order to develop my software system. This is a very important problem, as in the real life software is an industry, and therefore it's important that people is able to do forecasts on how much they will take to develop a software system and how much money do they have to ask for the development of such software system. The scenario in which you will adopt a similar type of techniques is, for example, if you will play for a big software vendor, and at a certain point a public administration or a company comes to you and asks the development of a new application, a web application. Your problem is how much time do I need to develop this software application, and how much money do I have to ask to the client in order to develop this software application and to have a reward for my work. This is the type of question that the software engineer should be able to answer, and there has been developed during the years different methods in order to do such an evaluation, and one of them is the function point. Notably, function point is the techniques that is adopted in Italy, in particular in all the contract and the call for tender that you may be part if working with the public administration. So typically, in order to measure software, there has been different software metrics, and in particular what we typically they are divided into two categories: the direct metrics and the indirect metrics. Direct metrics are those ones that you can measure somehow directly on the software, and among them we have, as an example, the one on the code. Example of direct metrics on the code are the lock, line of code, that is the number of line of code that has been written, the McCabe index, that is an index that was proposed in the past years to measure the complexity of the software, in particular how much cycle and decision points are present in the software. Other type of metrics are those ones that you can recover on the requirements of the software, in particular those ones that are based on the number of transactions that the software has to perform, like the function points that we will be analyzing, or there have been metrics that have been proposed based on object-oriented on the object-oriented models of the software, mainly from the research worlds, and many others. Indirect metrics are those ones that you can derive, for example, by basing on the service level agreement that your software is offering, or those ones that are considered the user opinion, for example, by collecting a questionnaire on the level of satisfaction that the software has with respect to its client. So the metrics that deals with dimension are mainly based on the line of code, and typically they can be, and many metrics are based on the line of codes. The concept of line of codes is very simple, is the number of lines of code, as the name says, and apparently is very easy to compute, because it's just looking at the source code of a program and counting how many lines has been written. but notably is strictly associated with the actual programming language and the programming style. All of you knows that you can write for the same code, you can write a very verbose code and maybe full of comments that are lines of code, or that you can adopt a style very clean, and other that writes code with a lot of inline expression that apparently makes the code very unreadable but very compact in terms of line of code. So the question would be, what is better, the first or the second approach? And of course, on the basis of line of code, I can have a lot of other measurements that are derived from the line of code. For example, the ratio between the internal errors in my code and the klog. Klog stands per 1000 line of codes. Or the external errors for klog for year. If we want to measure, for example, the percentage of errors that my development process produced, I can have the ratio between the documentation pages for klog. How many logs are written per person per month? What is the number of errors that are produced per person per month? What is the cost of a single line of code or k line of code? And what is the cost for documentation page? So once that you have the line of code, as we are directly measuring the software, it's very easy to derive many other metrics that are very important to evaluate the performance of your development process, if you like. As we said, the line of code are not apparently are easy to compute, but are too dependent on the programming language that is used. So during the years there will be proposed other metrics, and in particular one of these that is still widely used, as I said, in particular is adopted, for example, in the evaluation of software in the tender for the public administration in Italy, is the function point. Function point is a very old metric. It was proposed in the 1978-79 by Albrecht, and basically is an empirical formula based on functionalities. So the idea is that looking at the requirements of my software, I find a way to measure an abstract concept of functionality, we'll see, and I determine the dimension of my software on the basis of these abstract functionalities. During the years, several extensions has been proposed to the original proposal, and there is still an active group, IFPUG, International Function Point User Group, that you can check on the website, that still maintains the techniques and evolves the techniques in order to keep pace with the technological evolution that we have in the material. So the idea of the function point is represented in these figures. The concept of when you develop a program is the following one. You have an application that is the one being considered, is the one under investigation, let's say. And this application basically interacts on the one side with the user that is represented in the figure on the left, and on the other side it interacts with possibly other applications. So the idea of the function point is that I evaluate my application at the border. Which border? The border between the software under investigation and the user or other system. And what I do is that I consider to measure what is inside. So what is inside my application will be measured. What is outside, it will be not measured. And in order to do this measurement, I will consider some concepts that are the A, the AU, the EQ, that are valid both for user, as we will see, and for the another application. And then I consider internally the ILF. We'll see all these concepts, of course. So the idea of the function point in the evolution, in the version that was evolved in 1984 is the following one. I measure this AE, that is, I anticipate are called external input, and I count how many of them. And then I assign a weight to each external input, and this weight can be on a certain discrete scale. Then I measure the AO, that are the external output. Then I measure the AQ, that are the external query. Then I measure the ELF, that are the internal logical file, and the AF, that are the external logical file. And as of it, I give weight to each of them, depending on their complexity. On the basis of this weight, I derive some numbers, and I do the total. And then what is that I sum my value, possibly corrected on the basis of some factor, and possibly were defined 14 different factors that keeps into account different property of the software. I correct somehow with some factors. In particular, empirically was found this value that is 0.65 plus 0.01 for this linear combination of this correcting factor, that, as you can see, they weight for the 1%, and all this correction is multiplied for the total, and this determines the total function point of my application. This value is the dimension of the software that I want to measure. Of course, later we will see an example that will make everything more clear, of course. So let's see what are the concepts that I have to keep into account in order to do this evaluation. The first one is the concept of internal logical file. What is an internal logical file? An internal logical file is defined as a user-identified group, so it's in relationship with the user. This is very important to keep into account, of logically related data or control information that is maintained within the boundary of the application. So the primary intent of an internal logical file is to hold the data maintained through one or more processes of the application being counted. Somehow we can say, to give a simple intuition, this is the persistence level of my application. Then we have the external interface file. What is an external interface file? Is again a user-identified group of logically related data or control information that is referenced by the application. So your application should keep it into account, but is not maintained within the boundary of the application, but is maintained within the boundary of another application. So somehow we can say that it is a kind of external persistence layer. The primary intent of an external interface file is to hold data referenced through one more elementary process. An elementary process, you can have the intuition, is a transaction, so is a set of operations that my application should perform in order to carry on the work within the boundary of the application. This means, of course, that an EIF counted for my application for sure will be an ELF in another application, because I'm counting this in order to keep track of the application to application interaction. Then I have the external input. What is the external input? An external input is an elementary process that processes data or control information that comes from on the application boundary. So the intent of an external input is to maintain typically to one or more ELF or alter the behavior of the system. So I'm counting for what is coming from outside, and that typically in a traditional management type of software, as the most of the software that are built for OLTP, online transaction processing application, should be then persistent or updated internally. Then there is the external output. What is the external output? It is again an elementary process that may send data or control information outside of the application boundary. So the intent of an external output is to present information to a user through processing logic in addition to the retrieval of data or control information. It's important, this is in the original definition, that this processing logic that you do with the external output must contain at least one mathematical formula or calculation, so it should create some derived data that is maintained in one or more ELF or should alter the behavior of the system. So what the definition is telling us is that you, in the external output, you need to do some elaboration over the data. It's not simply visualizing the data, but you need to make some calculations. So there should be some computing. That is why you need to, we'll see, this will imply some code that is managed because you may want to do some calculation. And then you have the external inquiry. What is an external inquiry? It's an elementary process that sends data or control information outside of the application boundary. The intent is again to present information to a user to the retrieval of data or control information from an ELF or an EIF, but here the processing logic should not contain mathematical formula or calculation and should not create derived data. So in this case, there is no internal logical file that is maintained during the process, nor the behavior of the system is altered. This is, let's say, a pure visualization of the data. So you can appreciate the difference between the external output in which computing is performed and the external inquiry that conversely is simply to show the results of an inquiry. You can say a query, so it's a simple visualization task somehow. So what you do is that the function points are weighted on the basis of three weights that are low, medium, and high, L, M, H. And typically, so you have for each functionality, where the functionality are one of those 5 categories that we have seen in the previous slide, and you have to evaluate the weight of this functionality. And of course, the weights are different for the 5 functionalities. So what you do is that you create adjusted function point. So what you do is that when you have you have calculated the non-weighted function point, what you do is that the empirical formulas says that you can change plus minus the 35% through a formula, a corrective formula that captures what are the general characteristics of the system through a set of 14 indicators. That is, as an example, if I need to have a system that has a backup or recovery, or if I need to do a distributed system and so on. And typically what you do is that for each indicators you have to consider if it's not relevant at 0 or is essential. And then you do the sum of these of the value that I've given to the 14 indicator. This gives you a 1% basically, and 0.01 for this linear combination, and you have 0.65, and then you have multiply, and then you multiply this for the total. This was the original proposal of the adjusted function point that was metrically. We will not deal with this issue anymore, because we'll see that following methods has substituted this concept with the other one, in which function point will be used directly to do the estimation of the line of code and of the effort through the COCOMO that will be used in combination with the function point. But it's important that you are aware, because when the people can describe a function point, you should be able to understand if they are dealing with unadjusted function point, non-weighted function point, or with the adjusted function points that are very often called as AFP. So before going on, let's immediately consider what are the limits of the function point. So function points are very good point. The first one is the pros. The pros is that they are widely used and accepted. There are standards, there are active organizational, the IFPUG, International Function Point User Group, that are maintained, maintains the method active and produce continuously report and evaluation on how this method can be applied to the changing world of software engineering. There is a certified personnel available, so the capability to evaluate function point can be certified, and there are people that professionally are able to calculate function point with a very good degree of accuracy. The calculation is somehow objective because it is based on requirements. The unadjusted function point UFP are independent of the technology. Can be used in early development process because based only on requirements, it's very useful to be used during the requirements collection of a software system, and therefore you are able to do an estimation of the cost and time of your development without starting really the development. So they are very helpful during the development and are basically empirically has been considered enough accurate as the software slog. The cons is that what are the negative aspect, that semantically they are difficult. So they were based at the end of the 70s. The most of the development was doing Haiti, and so is basically they are a very legacy techniques and terminology that is difficult for teaching. You don't have only to think teaching to a university, but also teaching to professional. Imagine the case in which you should teach to a group of person in public of software engineering, public administration, and somehow you need to have a certain ability to be able to grasp really what function points are and how to apply. So another aspect is that they are somehow incomplete. So what is an internal functionality? If you think is something that measures the data size or the complex processing of the internal of the storage. So somehow is too abstract on some point. There is the lack of automatic counting, so you don't have system. You don't have system that allow you to evaluate the function point in an automatic way, and there are many different versions that were developed from the standard. So this is the pros on one side, but on the other side is also difficult because this means that you should also, when dealing with someone, be assured that you are using the same version of the function point in order to evaluate. So the important is that as everything in the real world there are pros and cons. The nice fact is that, and this is why we are looking at them into the courses, that they are really used in project, and as I said, they are the standards methods, for example, to evaluate the software in tender for the public administration in Italy. So they are surely methods that has an applicability, at least because there is someone that is public administration is a large client of the software industry in Italy and all over the world, and therefore they are helpful to be used for evaluating this type of software system. So it's important to consider the relationship between line of code and function point, and this is a table. This is a quite old table that, but more or less the number that gives what is the translation, let me say, between a function point, a line of code for function point. So empirically, they demonstrated that if you're writing code in assembler, 320 lines of code are produced for realizing one function point. Conversely, if you use a 4GL, 4th generation language, an example of 4th generation language is Visual Basic, so or those programming, or can be Visual C#, for example, you have 20 lines of code. If you write in C++ or Java, is only 30 lines of code for a function point. If you consider C, is 128. If you consider COBOL, that was the programming language of the legacy system that is very low level like C, you have 100 line of code, more or less the same as Fortran. If you use an electronic spreadsheet like an Excel with macro, that is a way in which you can think to implement simple transactional processing, it will be more or less 6 lines of code. So what this table demonstrates you is that the function point is very helpful on one side because it's independent on the technology, but also demonstrate you that the level of complexity in writing the code, once that you have derived the function point, is very dependent then on the programming language that you may want to adopt in your system. And sometimes you are free to choose such a programming language, but other times it's an architectural constraints of your software system, because for example, your software architecture is written in a particular programming language, and therefore there are constraints that you may want to consider. Now let's see. Let's start now that we have seen a first round of the concept. Let's see how you can compute the single element of the function point, and we'll start by considering the data functionalities. And data functionalities are concerned with the ILF and the HEIF, that I remind you are the internal logical file and the external interface file. So the internal logical files, I remind you the definition, because they are quite, as we said, they are semantically strange for us, is a user identifiable group of logically related data or control information which is maintained within the boundary of the application. The primary intent of an internal logical files is to hold the data maintained through one or more elementary process of the application being counted. The external interface file, conversely, is an external interface file, is a user identifiable group of logically related data or control information that is referenced by the application but maintained within the boundary of another application. The primary intent of an external interface file is to hold the data referenced through one or more elementary process within the boundary of the application counted. And incidentally, this means that an EIF counted for an application should necessarily be an ELF in any other application. So how do you measure this? You measure through the two concepts that are the det and the ret. What is the det? The det is a data element type. So basically is a user identifiable single field within an ELF or an EIF. And the ret is a record element type, so it's a user identifiable group of fields within an ELF on the EIF. And the way of computing the complexity of an ELF if is to count the number of ret that you may derive for it. And typically this is a conversion matrix that was derived by the standard organization that are maintaining the function point. If you have one ret and between 1 and 9 and 19 that you are low complexity. If you are between 2 and 5 ret and the number of that is between 1 and 19, you are still low. And if you are 6 or more ret and you are within 1 or 19 that, you are medium. If conversely you are between 20 and 50 that, you are low, medium, and high respectively. If you have more than 51 that, the complexity is medium or high And typically you assign different weight. So low typically is 5 or 7, medium is 7, 10, and high is counted between 10 and 15. So this is a table that we should keep into account because it helps us to do our calculation. I understand that now everything can be quite abstract, but then we will see with an example. We'll develop a fully fledged example in evaluating a software system, and you will see that the game is much simpler than you can imagine, of course. Now let's deal with the transaction. The transaction, so the computing that you may want to do over your data item. And in order to consider the transaction, we should deal with external input, external output, and external inquiry. And let's look again at the definition. An external input is an elementary process that processes data or control information that comes from outside the application boundary, and the primary of an external input is typically to maintain one or more internal logical files or to alter the behavior of the system. So basically what it's saying is that the external input or is the need to acquire data and possibly to create a new data item or to update existing data item, if you want to describe in a way that is more similar to the modern way of describing stuff. An external output is an elementary process that sends data or control information outside of the application boundary, and the primary intent of the external output is to present information to a user through processing logic to the retrieval of data. So you should not only retrieve data in order to visualize, but you need also to process such data. This is very clear in the definition because it said that the processing logic must contain at least one mathematical formula or calculation, or should create derived data that is maintained by one or more ELF, and or should alter the behavior of the system. So that should be really computing over the basic data item. And then you have the external inquiry, that somehow is the counterpart of the external output, because it said that an external inquiry is an elementary process that sends data or control information outside of the application boundary. In this case, the primary intent is again to present information to a user through the retrieval of data or control information, but here the processing logic should not contain mathematical formulas or calculation and should not create derived data, but in this case no maintenance is done on internal logical files, or the behavior of the system is altered. So basically this is a pure, we would call a query, if you like. And what these tables helps you to identify. So, and in which the tables remind us. So, as an example, an external input can validate item, can do math calculation, can select data using a specific criteria, can evaluate Boolean condition, must is the primary goal, must update one or more internal logical files, can read one or more internal logical file or external interface file, can get some control data, can compute new data, must again change the system behavior, can find data and present them outside of the application boundary, must acquire control of the data produced outside the application boundary, and can manipulate the data, for example, doing a sorting. An external output conversely can validate the data, but must do math calculation, can select the data using specific criteria, can evaluate Boolean condition, must update one or more internal logical file, can read one or more file, basically internal logical file or external interface file, can get some control data, must compute new data, must change the system behavior, must is its primary goal, find data and present them outside the application boundary, can acquire control data produced from outside the application boundary, and can manipulate the data. The external query that you will see as you have in particular to look at this column by comparing with the external output, can validate the data, cannot perform a math calculation, can select data using specific criteria, can evaluate Boolean condition, but cannot update one or more internal logical file, must read one or more internal logical file and external interface file, and must get some control data, cannot compute new data, cannot change the system behavior. Its primary goal is to find data and present them outside the application boundary, can acquire control data produced outside, and can manipulate the data. So this table should help us to correctly understand what are the elements that we may want to use. How do you measure the complexity? How do you evaluate the complexity of the transaction? Typically, you consider the FTR. FTR are file type referenced, and typically what you will do is that you will count how many FTR are changed or read by in the ELF or from the EIF. So you are measuring how much reference to ELF or EIF you consider, and in doing this you measure the depth. So what are the single field? Remember that we saw as well when dealing with the ELF and the EIF. So what are the fields that you consider within the internal logical file or external interface file? And here we have the table as well that give us the complexity of the transaction. So let's see initially for the external input. So if you have between 0 and 1 FTR until you are till for that you are low. If you are between 5 and 15 you are again low. If you are more than 16 that you are medium. If you are 2 FTR, you have respectively low, medium, and high. If you are 3 or plus FTR, you are medium, high. But here, as you can see, low is counted as 3, medium is counted as 4, and high is counted as 6. Remember, conversely, that when we look at EIF or ELF, we were counting, for example, high was between 10 and 15. Why? Because of course the code for maintaining the data is more complex, so count more than the code for acquiring the input. If conversely we look at the external output or external inquiry, we see that the value are a bit higher, because if we are between 0 and 1 FTR, we have between 1 and 5 that we have low, that count here between 3 and 4. If we are between 6 and 19, that we are low, that counts are 4, 3. If we are more than 20, that we are counting as medium, where here medium evaluate 5. If you are between 2 and 3 FTR, we have respectively low, medium, and high, where high here count as 7, and plus or more FTR, in this case we count as medium and high, medium, high, and high respectively, where high is counting as 7. Now let's have a 5 minutes break, and then we'll go to see a simple example. Okay, let's restart our study of function point by looking at an example, an initial example. And in particular, we will consider an invoice database that is a traditional OLTP-like application. So what are the requirements if you have to develop an invoice database? Typically you have a sales division that wants to handle the following customer information when managing the invoice: the name, the fiscal code or the VAT number, partita IVA in Italian. Then you have the legal address, the corresponding address that may be different from the official fiscal address, a phone, and the invoices for each customer that have been produced. And then what you want is that for each invoice, typically you have an invoice number, an issue date, the date in which the invoice has been paid, and for each item of the invoice you want to have the description, the number of items that you have bought. It is the percentage of VAT that has been applied, because you know that if you do online shopping, for example, in this period, you know that not all items have the same VAT number. Some of them are the VAT is 22%, others are 10%, and there are many different. In Italian are called aliquota, so there are different percentage of VAT that is applied. Then you want unit cost. In our application that we are considering, we know that the description, the percentage of VAT, IVA, and the unit cost is typically come from an external application that is the warehouse application. If you think this example is how to evaluate the function point on a piece of an application like Amazon, like as an example, in which you have typically a warehouse service and you have the invoice service that is managing this part of the customer relationship management in the overall information system of the seller. So let's start. For the functional requirements, we need to estimate the function point of the application that will allow for inserting, deleting, editing, and viewing the customer and the invoice, and we know that the customer search typically is carried out using the fiscal code, while typically the search of the invoice is done by considering the invoice number. For the then we have a second functional requirements, that is we want typically to print the invoice on the screen and to visualize it. And typically when we produce an invoice, what we want to print is a nice format of the customer name, the VAT number, the fiscal code, the legal address, phone, the invoice number, the issue date, and printed 1-4 line, the item, how many items have been bought in this transaction, what is the percentage of the VAT, the unit cost, the total, and what is the total of the VAT paid. And typically you want to printing a customer at screen or also to visualize it, and in this case you have a kind what we could call an anagraphic form, let me say, that is the customer name, the fiscal code, the VAT, the legal address, the corresponding address, and the phone. Now, in order to make the calculation, we should deal with the 8, remember, internal logical file and external input file. So one approach that over the years and has been considered is to not to deal with so low level, but to have conceptual schema. Remember that we are dealing with functional requirements, and we know that conceptual schema are easy, has been proposed easily to work conceptually, so independently of the result storage technology. So we don't want really to consider. So one up to consider how the data are stored in a record or file or whatever. So one approach is to have an entity relationship like representation of our system. Remember, this is not mandatory. Function point are an empirical techniques. So this is one of the empirical suggestions that over the year have been proposed in order to make this calculation meaningful. So if you should model the portion of the entity relationship schema of our application, probably you will arrive at this schema. You will have a customer that is represented with a set of attributes that are the name, fiscal code, VAT number, phone, legal address, corresponding address, which has a relationship relationship 0n with invoice. So a customer has potentially 0n invoices, and an invoice belongs to exactly one customer. Remember that in entity relationship schema the cardinality are done in the other way that in UML diagram that probably you are more used with. You have an invoice. An invoice is represented by an invoice number, an issue date, and a payment date, and the primary key is the invoice number. And typically an invoice consists of 0n item, where on the relationship we have how many items are part of that invoice, so it's an attribute of the relationship, and an item is characterized by a description, an aliquota, in English you can call VAT percentage, and the cost. So an item belongs in general to, if an item is a part of an invoice should have at least one or multiple items, and an item can belong to 0 or multiple invoices, of course. Of course, you can understand that if you are not willing to use entity relationship schema, you can use UML class diagram as well, that they are analogously valid for the purpose of our calculation. So at this point, once that we have this conceptual schema, it's simpler to evaluate the ELF and the AIF. And in particular, we understand immediately, looking at the schema, that in our application we will have two internal logical files, one for the customer and one for the invoice, and we have, as the requirements told us, we have one AIF, that is the item, because it was told us that the information about the item are not maintained by our application, but are derived by an external application, the warehouse. You remember it was written in this slide, the slide 22. So now let's start to evaluate the complexity of each of them. So for the customer, how many records do you have? Remember the definition? Of record elementary type is a user identified group of fields. So in our example, remembering this schema, it's quite immediate to see that for the customer we have 1 ret, a 6 det. How do we measure the 6 det? Basically are the attributes that we have. This is why it's simple to have an entity relationship schema. It should not be said, but the intuition that we are using is that basically, if we have an entity relationship diagram, the tables that may correspond to a possible implementation of this schema are exactly our ret and the attributes. So the column of the tables are exactly our det, and so we have 6 det. For the invoice, we have 1 ret and 4 det. Why we should have 4 det? Because they are the 3 attribute plus the number of items, because of course, assuming that you are recovering the information of the item externally, a way of storing this information would be to have an implementation in which the number of items will become an attribute in the table invoice. This is a straightforward way of implementing this model. And for the item, that is an if, you have 1 ret and 3 det, because these are the attributes. So let's remember the table of the complexity. This means that we have, for the 2 ELF, as we have 1 ret and 4 or 6 det, we are for sure in this cell. So we have low complexity. Low complexity, assuming that we are taking the higher value, so it's let's take 7. This means that we have 14 function points. For the if, we have 1 ret, 3 det, so for sure we are here, and we take 5. Here you may ask why you are taking 5 instead of 7, and in the previous case we are taking 7. It's here it's matter of, as we'll see, it doesn't change too much, but it's matter of practice somehow, because in the external we are using 3 det, in the other case we were 6 that were exactly the double, so it would make sense to consider higher number for the internal logical file, and also because in general the internal storage is more difficult to implement than the external access to data. Imagine in the case of recovering the item, in the concrete terms would mean to make a query to through an API to the external warehouse application for having 3 fields is really simple. So we would keep the lower complexity possible, that is the 5. Now let's see the transactional part, and in particular let's start to consider the external input. For the external input we have, for the transaction, looking at the requirements, we have 6 external input. Why? Because we need to do the insert, the delete and the update both for customer and invoice, as it was written in the specification. Estimate the function that allows for inserting, deleting, editing, viewing customer and invoicing, and then there was the search part. So we have the primary goal of this transaction was to update the corresponding internal logical files. Please note that we have exactly 1 internal logical files both for customer and invoice. So now let's look at the complexity. In this case we have, of course, the insert of the customer is dealing with 1 FTR. Let's remember FTR is the file type reference, that is changed or read, and then we have to consider how many that. So for the customer we have 1 FTR and 6 det, because when you insert a customer we are inserting all the data. For deleting a customer we are 1 FTR and 1 det, because as we said you enter directly through the fiscal code of the customer you may want to delete. For the update of a customer you have 1 FTR and 5 det. Why 5 det? Because it was a 6 det, but 1 you should consider 1 less, because the fiscal code is the key that you will allow us to enter, so you are not updating the key, is the primary key. For the invoice, the insert should imply 3 FTR. Why? Because an invoice is externally referenced by the customer, because you don't have directly the invoice, you have the invoice and the customer, and then you have also to access the items that are part of the invoice. So you are accessing, when creating an invoice, when inserting an invoice, you are accessing both the 3 files. So the FTR are 3, and for doing an invoice you have 8 det. Why you have 8 det? Because you have the 3 of the invoice plus the 3 of the item plus the number of items of the item, plus you need to create the relationship with the customer, so you have the fiscal code. For the deleting of an invoice you have 1 FTR and 1 det, because it was written in the specification that you can enter directly with the invoice number. And for the update of the invoice you have 3 FTR for the same reason of before, and 3 det, because again the invoice number is the key and you don't have to consider it. So what is now the transaction complexity? The insert and the update are high and the others are low. Why this? Because let's remember our table. So if you have between 0 and 1 FTR, between 1 and 5 det, 1 and 4 det, you have low. So now we have, it's reported here in the slides, it's simply the snapshot of the previous slide, that for the insert of the customer is 1 FTR, 6 det. So we are in this cell. For the delete of the customer we have 1 FTR and 1 det, so we are here. And for the update of the customer we have 1 FTR and 5 det, and so we are here. So basically we have 1, 2 and 3 of type low. Then what we have for the invoice, we have 1 that is simple, the delete, because it's 1 FTR, and so we have 4 low, considering 3 for each of them, it's 12 function point. For the insert and update, conversely we had 3 FTR, so we are in the last row of this table, and we have 8 or 7. That means that you are surely in the second category, that is high, and so we have 12 function point. Now let's go to consider the other transaction, that is the external output. The requirements told us that we need 2 types of transaction of type visualizing producing output, let me call in this way. That was the printing of the invoice. So for the printing of the invoice we don't need nothing as an input, because it's simply triggered from the invoice view. If you have to imagine an application, you would while scrolling down all the invoices you will print one of them. So and what you need as an output, typically you need 3 FTR. Why you are dealing with 3 FTR? Because again we have seen before you will need to link the invoice, the customer, and the item. And in this case, the data are 10. If we look at the specification, because you need the name, the fiscal code, the VAT number, the legal address, the issue date, the number of invoice, the description, the percentage, and the cost, and the number of items for the single law. So in this case, let's remember that is reported here with the table between the external output and external inquiry. If we have 3 FTR with 10 data, we are basically in the medium category, and we can consider 5 function points. Why we consider that is an external output? Because it computes derived data. For example, the total of the invoice. The total of the invoice is something that we need to compute when printing the invoice. Let's remember that also that according to the definition, data derived are not debt, so they are not considered in the calculation. Then we have another transaction that was the printing a customer. In this case, we will see that is an external inquiry because the customer is already present in the system, so you should only simply find it and present it. So again, as input there is nothing, it's simply triggered from the customer view. The output is 1 FTR, the customer, and 6 det. So 1 FTR and 6 det, if we look at the table, is very simple, it's low. And so we are considering 3 function points. Again, between 4 and 3, we consider 3 because it's really a low number of evaluation. This means that the function points that we had 19 function points that were derived from the computing from the internal logical file and external logical file. 24 that were derived from the external input, 5 for the external output, 3 for the external inquiry. Total, we have 51 function point, unadjusted function point, that is the total number. Now, if we want to evaluate how much it would require to develop this program, we should say, by considering the conversion table, that if we would program in Java, this would be more or less 1,500 lines of code, or if it was in assembly, it would be about 16,000 and more lines of code. Okay, so we have seen the function points, and we may want to have a second exercise after, we will now consider a second exercise after a further break.